Have you ever wondered how the roaring power of your car's engine makes its way to the spinning wheels on the road? Central to this mechanical marvel is the gearbox, a true hero under the hood. It adeptly converts the engine's raw power into a finely tuned force that propels your vehicle forward. Through a symphony of gears and shafts, this clever device ensures that the right amount of power reaches the wheels at the right time. This crucial process starts with the first key component, the input shaft. The journey of power begins at the input shaft. This crucial component serves as the primary conduit through which the engine's roar transforms into useful motion. Attached directly to the engine's crankshaft, the input shaft is where the dance of dynamics starts. As the heart of the engine beats, its crankshaft spins, eagerly transferring its rotational force directly to the input shaft. Imagine the input shaft as the first domino in a chain. When the engine flexes its muscles, the input shaft receives this raw energy with open arms. It's here that the engine's torque, that fundamental force of twisting power, is first harnessed. This shaft is not just a passive receiver though. Oh no, it's an active player in this mechanical ballet, dynamically channeling that vigor into the gearbox. Its role? To take the torch of torque from the engine and carry it forward, setting the stage for a symphony of gears. With the engine's power in hand, the input shaft then hands it off to the real game changers inside the gearbox, the gears. Inside the gearbox, a team of gears awaits to take the stage. These mechanical marvels are not just lumps of metal, they are the maestros of motion, orchestrating the transmission of power from the engine to the wheels. Let's delve into how these gears work and their crucial role in driving dynamics. The heart of the gearbox is its gears. Arranged meticulously in pairs, these gears come in various sizes, each pair designed to handle a specific gear ratio. This ratio is a measure of how many times the input shaft, connected to the engine, needs to rotate to turn the output shaft, which ultimately spins the wheels once. For instance, a gear ratio of 3:1 means the input shaft rotates 3 times for every 1 rotation of the output shaft. These varying gear ratios are what allow a vehicle to accelerate from a standstill to high speeds, climb steep inclines, or cruise efficiently on highways. When the engine turns the input shaft, it engages one of these gear pairs. The chosen gear pair then dictates how power is translated to the wheels, influencing how fast they spin relative to the engine speed. Imagine driving through a city. Lower gears with higher ratios are used. These provide more torque or turning force at lower speeds, which is great for starting up or climbing. Conversely, on a highway, higher gears with lower ratios are preferable. They reduce engine load and allow the vehicle to maintain high speeds without overworking the engine, enhancing fuel efficiency. The magic of gears doesn't stop with just speed and torque adjustments. They also play a pivotal role in the feel and responsiveness of a vehicle. The smoothness of gear transitions and the accuracy of power delivery can significantly affect driving comfort and vehicle performance. Selecting the right gear is crucial, and that's where our next component comes into play, the gear selector. Who decides which gear to engage? Enter the gear selector. In the intricate ballet of automotive mechanics, the gear selector plays a pivotal role, acting as the conductor of power transmission. Let's delve into how this crucial component functions in different types of transmissions. Starting with manual transmissions, the gear selector is more commonly known as the gear lever. This lever, when manipulated in conjunction with the clutch pedal, allows the driver to manually choose the appropriate gear. As the driver presses down on the clutch pedal, the connection between the engine and the transmission is temporarily severed. This disconnection permits the gear lever to slide into the desired position smoothly. Once the new gear is selected, releasing the clutch pedal re-establishes the connection, now with a new gear ratio set to meet the demands of speed and torque. Switching gears, quite literally, to automatic transmissions, the scenario changes. Here, there's no need for a manual clutch or even for the driver to select each gear. Instead, The transmission system automatically determines the optimal gear based on various factors such as the vehicle's speed, engine load, and even the incline of the road. This automatic decision-making is facilitated by a complex dance of hydraulic pressure, electronic sensors, and computer algorithms, all designed to deliver the smoothest and most efficient driving experience. With the correct gear selected, the baton passes to the output shaft. Now, we reach the final stretch of our power journey, the output shaft. Imagine the output shaft as the valiant courier in the complex postal system of a gearbox. It has the critical task of delivering the power and torque which have been meticulously adjusted by the gears right to the wheels of the vehicle. This shaft doesn't work in isolation though. It's the culmination of a series of precise mechanical ballets happening within the gearbox. The output shaft receives power from the engine that has traveled through the input shaft, danced between the gears, and is now ready to make the wheels spin. But it's not just about transferring power, it's about modifying it. Depending on the gear selected, this shaft adjusts the speed and torque of the rotation. This adjustment is what allows your vehicle to accelerate when you're trying to pass another car on the highway or to crawl in heavy traffic. This shaft's ability to alter torque and speed depending on the vehicle's needs is fundamental. For instance, when climbing a steep hill, the output shaft ensures that more torque is delivered to the wheels, giving them more turning power, even if the engine isn't running any faster. Conversely, on a flat highway, it supports higher speeds with less torque. The output shaft's role in the final delivery of power is not just about turning the wheels, it's about ensuring that the vehicle moves according to the driver's demands smoothly and efficiently. But what ensures these transitions are smooth? Let's talk about the clutch and the torque converter. Shifting gears smoothly is an art, perfected by either the clutch or the torque converter. In the symphony of automotive mechanics, these components act as the crucial intermediaries between the engine's raw power and the rhythmic dance of the gears. In manual transmissions, the clutch is the hero of the hour. When a driver presses down on the clutch pedal, a fascinating mechanism springs into action. The clutch disengages the engine from the gearbox, effectively severing the flow of power. This pause is critical. It's the breath between notes, allowing the driver to select a new gear without grinding the gears or stalling the engine. Once the new gear is engaged, releasing the clutch pedal re-establishes the connection, and power flows once again, propelling the vehicle forward. Transitioning to automatic transmissions, the scene changes slightly, featuring the torque converter. This device replaces the manual clutch with a fluid-driven marvel. Here, hydraulic fluid transfers the engine's power to the gearbox through a seamless, variable flow. The torque converter adjusts this flow based on the engine's speed, ensuring that power delivery is not only smooth but also intuitively aligned with the driver's demands. Whether accelerating on a highway or maneuvering through slow city traffic, the torque converter adjusts effortlessly, making the driving experience feel almost telepathic. Each component plays a vital role, ensuring your vehicle runs smoothly and efficiently. So, we've journeyed through the complex yet fascinating world of the gearbox. Let's take a moment to recap and appreciate how each component plays a pivotal role in your vehicle's performance. Starting with the input shaft, this is where the magic begins. It's the bridge that carries the roaring energy from the engine's crankshaft straight into the heart of the gearbox. Without it, the dynamic power of your engine wouldn't even reach the gears. Speaking of gears, these are not just any pieces of metal. They are meticulously crafted to mesh perfectly, each pair designed to provide a specific gear ratio. This ratio is crucial as it determines how fast your wheels spin in relation to the engine speed. Whether you're climbing a steep hill or cruising on a highway, it's the gears that make it possible to adjust your speed and torque so precisely. Now, shift your attention to the gear selector. Whether it's the manual thrust of a gear lever or the seamless automation in an automatic transmission, The selector is your direct line to commanding this power. It's how you, the driver, communicate with your car, telling it how fast or how powerfully you need to go. Then we have the output shaft, an essential exit point for all that adapted power, channeling it towards the wheels. It's here that the adjusted torque turns into actual movement, pushing you forward on the road. And we can't forget the clutch and torque converter. In manual transmissions, the clutch masterfully disconnects the engine from the gearbox, allowing for smooth gear shifts. In automatics, the torque converter takes over this role, using hydraulic fluid to transfer power efficiently, ensuring that you experience that smooth ride without manual intervention. Together, these components orchestrate a complex ballet of mechanical prowess, managing your vehicle's power and speed with astounding efficiency. Next time you shift gears and feel the smooth acceleration, remember the intricate dance happening within the gearbox, the unsung hero of your vehicle's mechanics.